Hey guys, welcome to GeeklyEDU. My name is Eddie, and today we will be talking about infinite series. Now, in order to fully comprehend what an infinite series is, we need to talk about infinite sequences. Now, an infinite sequence, a sub n, for example, let's say it's going to be equal to n squared, where n is greater than or equal to 1. So a sub n is basically going to be a list of numbers. So it's going to be 1 squared, 2 squared, 3 squared, 4 squared, etc. And that's going to go all the way up to infinity. Now, what happens if we want to add up all these numbers? Okay, we want to create 1 squared plus 2 squared plus 3 squared plus 4 squared, etc. We want to know what that number is going to be equal to. Well, this thing right here is an infinite series. So an infinite series is just the summation. It's the summation of the terms in an infinite sequence. And usually it is going to be denoted by the capital Greek letter sigma. Okay? So whenever I write sigma a sub n, what I'm saying is that I'm going to do the sum of all the terms in a sub m. However, we also need to find a way to communicate which terms I'm going to be adding up, because I have an infinite number of terms. So do I start at 1 squared? Do I start at 3 squared? Do I want 10 numbers, 1,000 numbers, 10,000 numbers? So I create a counter, which is going to be from n equals 1. So this tells me where I start. So I start here, all the way up to infinity. Okay? And this gives me the summation of all the terms in the infinite sequence a sub n. Now, whenever I have an infinite series, there will be two scenarios. This will either converge or diverge. And we're going to do a couple of examples to kind of study what each of these terms actually means. So in example number 1, we're going to assume that we're going to use the same one we were using before. So we have summation from n equals 1 to infinity of n squared. Okay? So this is, as we had stated before, 1 squared plus 2 squared plus 3 squared, etc. So in order to get a good look of what's happening, I'm going to write the partial sums. So S1 is 1 squared. S2 is going to be the sum of two numbers. So 1 squared plus 2 squared. So this is 5. S3 is going to be 1 squared plus 2 squared plus 3 squared. And this is going to be equal to 14. And so on and so forth. So just by looking at this, we can already know that the more numbers I add up, I'm just going to get closer and closer to infinity. So what is this going to look like? Let's imagine that I want to graph the partial sums, and I want to see what's happening. Well, very simple. I start right here. So I start at 0. Then when n equals 1, I'm here. When n equals 2, I'm all the way up here, 5. When n equals 3, I'm all the way up here, 14. So you can see right away that the more the larger n gets, this is just going to approach infinity. Whenever this happens, we'll say that the series is divergent. Okay? It diverges. All right? Now, sometimes, even if we add up an infinite number of numbers, we can actually calculate the result of the sum. Not all the time, but it depends on what we're working with. So, let's create another example. Now, we're going to have series where n goes from 1 to infinity of 3 divided by 10 to the power of n. Okay, so this is going to be 3 divided by 10 to the power of 1 plus 3 divided by 10 to the power of 2 plus 3 divided by 10 to the power of 3, and so on and so forth. Okay? Which is the same as 0.3 plus 0.03 plus 0.003, so on and so forth. We repeat the same process we did before. We're going to say, well, S1 is 0.3. S2 is 0.3 plus 0.03, so 0.33. S3, a little bit more of the same. So this is 0.333. So we can see that the more numbers we have, we're just going to be adding more threes at the end of the same number, basically. So if we do the same graph we did before, and S sub n here, so we start at 0. We go all the way to 0.3 here. And then here we're just going to be slightly above 0.33. And then here basically the same, and then here basically the same, and it's just going to basically, it's going to be like as if we had an asymptote here. So the values are going to approach 1/3 or 0.333, like an infinite number of threes. So in this case, we will say that the series is convergent, or the series converges to 1/3. So I know this is really crazy, guys, but remember, you can always comment any questions that you have, and we'll try to get back to you. And definitely stay tuned for more videos, because every day we will be posting more videos regarding math, different science topics. Some will be related to this. And remember just to, like, subscribe, etc. So, to give a final overall view of what's going on with infinite series. An infinite series is the summation of the terms in an infinite sequence. We have all these terms, and we want to know what happens if I put them all together. Whenever I have a series, which is denoted by the Greek capital letter sigma, I need to have a counter. This is very important, guys. This tells you where you start. This tells you where you finish. I will have either a convergent series or a divergent series. In a divergent series, the more terms I add, I'm just going to have an increasingly larger number. So it's just like gonna get like bigger and bigger and bigger every time as it goes to infinity. A convergent series, on the other hand, the more terms I add, I'm just getting closer and closer to the same number. So I have 0.3, then 3.3, then 3.33, but I'm always approaching the same value, which is effectively 1/3. So that was it, guys. I hope you liked the content. Please remember to like the video, subscribe to the channel, please turn on the notifications so you can know when we post more videos. And remember, you can ask down in the comments any questions you have, and we'll try to get back to you as soon as we can. Have a good day.